close your eyes and, picture a starship, a vessel for peaceful, optimistic exploration.
Mm.
The shape that comes to mind almost for everyone is the USS Enterprise.
Oh, absolutely. That silhouette is iconic. You've got the huge, beautiful saucer section, the primary
The
hull.
way the engineering section just hangs below it, and then those two majestic warp nacelles sticking out into space on what look like impossibly thin pylons.
It's an icon, no question. It represents this whole vision of the future of human curiosity reaching for the stars.
It is. It's a masterpiece of cultural design. It's elegant. It's instantly recognizable.
And it just screams utopian future. But for this deep dive, we're going to take that beautiful, optimistic symbol and put it through a truly grueling trial.
We're basically ripping the blueprints off the wall.
We are. We are examining the Enterprise, and really its entire family of ships, through the cold, harsh, and frankly unforgiving lens of modern aerospace engineering, naval architecture, and military tactics.
So we're asking the question that people don't usually ask. What if this cultural icon, this flagship of Starfleet, is fundamentally a structural, tactical, and safety disaster?
That is the core of our mission today. We're doing a critical analysis of that classic Starfleet design, what's often called the Jefferies Configuration, and we're basing it entirely on this highly detailed, and I have to say, brutal assessment provided by a longtime fan and critical analyst who goes by the handle Eximus Old Type.
And his credentials here really matter. I mean, this isn't just some casual critique. According to the author, he's been deep in this universe for over 4 decades.
40 years. So this assessment comes not from malice, but from this profound, deep, and you can tell frustrated love for a design that he argues is just fundamentally flawed.
And his central thesis is just damning. It's crystal clear.
It is. According to the author, Starfleet designs right from the very beginning prioritized aesthetics over function. They look incredible on screen, which is great for television, but structurally, mechanically, they rely way too much on what he calls space magic.
Space magic. So fictional tech that has to constantly override the basic laws of physics just to keep the ship from, falling apart.
Exactly. And the overall crushing verdict, according to the author, the entire lineage of these ships, from the original Constitution class all the way through the Galaxy and Sovereign classes, they are fundamentally unsound, tactically exposed, and just dangerously fragile in a real combat situation.
Wow. Okay, so before we dive into the specific flaws, we probably need to define what we're talking about, the Jefferies configuration.
We do, because this specific layout is the target of the whole critique. This design was set by Matt Jefferies for the original Enterprise, the NCC 1701, way back in the mid-60s.
And it's a 4-part design that, once you really stop and think about it, it's a very unusual layout for any kind of vehicle, let alone a starship.
It is. So first, you have the primary hull. That's the iconic saucer section. It typically holds the bridge, crew quarters, and the main shields.
Okay, part 1.
Second, you've got the secondary hull, that sort of large cylindrical body that hangs underneath. That's main engineering. It's got the reactor, life support, the deflector dish.
And then part 3, the structural nightmare, as the author calls it, the connecting dorsal.
The neck, yeah.
Yeah.
The single, notoriously thin column that links those two massive hulls together.
A single point of failure right there.
A huge one. And finally, the most distinctive and arguably the most structurally flawed part, the warp nacelles, the engines. They're extended way out, suspended by those really thin, really long pylons.
And the author, Old Type, he even cites the history here, saying this bizarre shape came from a negative brief from Gene Roddenberry back in '64.
Right. Roddenberry specifically told the designers, no rockets, no jets, no wings. He insisted the ship had to look totally unique and futuristic.
And that's what led to this paradox.
That's what the author calls the engineering paradox. It was a conscious decision to detach the main propulsion system, which has all these massive, heavy energy components, from the main mass of the vehicle itself.
And according to the author, that's where the whole design just betrays the most basic laws of mechanics.
That's the original sin of the design.
Okay, that sets the stage perfectly. Let's get right into the heart of the physics critique then. Section 1. Structural integrity failures and the flaw of cantilevers. We're starting with just how the ship struggles to move in a straight line.
We have to begin with the most foundational concept in any kind of high-speed vehicle design: the relationship between the center of mass, or CM, and the center of thrust, CT.
This is like day 1 of rocket science, right? For any plane or ship or rocket trying to accelerate smoothly.
It is. If you want to move forward without spinning or tumbling, the line of thrust from your engines has to pass directly through the center of mass of the vehicle.
If it doesn't, you get torque.
Exactly. If that thrust line is offset, even a little, it generates torque, which is rotational force. In aerospace, keeping your CM and CT aligned it's paramount for stability.
So let's look at the original Constitution class Enterprise. According to the author's assessment, where does the center of mass sit?
Well, given the sheer size and, density of the saucer and the secondary hull, which has the reactor and all of main engineering, the CM would likely be somewhere deep in the center of that secondary hull.
Okay, deep inside the main body.
Maybe even slightly above it, but definitely centralized between those two huge components.
But the nacelles, the engines that provide the thrust, are mounted way higher and wider.
And that's the key flaw the author identifies. Because those nacelles are placed so high and off to the sides, the moment you fire the engines, it generates what he calls a massive downward torque.
Like pushing a heavy box, but you're pushing on the top corner instead of the middle.
Perfect analogy. The box wants to tip over. And in space, where you're trying to hold a course, that constant torque means the ship would always be trying to pitch forward. To nosedive, basically, the second the warp drive or high impulse engines kick in.
So the ship can't even accelerate smoothly on its own. It's inherently unstable.
It is, which means Starfleet has to waste a ton of energy just correcting for its own bad design.
How do they do that?
Well, according to the author, the ship has to constantly fire its maneuvering thrusters or, and this is the key, constantly adjust the subspace field geometry, which is basically the hand-waving needed to make the physics work. It's an engineered fix that has to perpetually fight against its own unsound shape.
And that's not just inefficient. That must put incredible stress on the whole structure.
Enormous amounts of stress and wasted energy that, could be used for shields or weapons.
It's fascinating, though, because the critique does point out that later on, designers seem to have realized this was a mistake.
They did. Eximus Old Type gives the Galaxy class, the Enterprise D, some credit here. The designer, Andrew Probert, clearly tried to fix the CMCT problem by lowering the nacelles.
Right, on the D, they're much lower, almost parallel with the bottom of the secondary hull.
Exactly. It was an attempt to move the center of thrust closer to the center of mass, and it was an improvement, for sure.
But not a complete fix.
No. In the author's analysis, the core structural problem is still there. The engines are still external, mounted far away from the main body. They still generate these significant moment arms that amplify any tiny instability during a quick turn or a change in velocity. The problem is smaller, but it's still baked into the ship's DNA.
And those external mountings, no matter how high or low they are, that leads us right to the next huge flaw, the pylon vulnerability. These aren't just for looks. They're engineering nightmares.
Oh, absolutely. Old Type emphasizes that from a pure material science view, the pylons holding up those heavy warp nacelles are classic cantilever beams.
Okay, for those of us who skip mechanical engineering class, explain what a cantilever beam is and why it's such a terrible choice here.
Think of a diving board. It's only secured at one end, where it connects to the hull, and the entire weight of the nacelle, plus all the dynamic forces of maneuvering, is carried by that one single connection point.
And all the stress is focused right there at that joint.
The highest stress, yeah. And it gets worse because of leverage. The author brings up the basic calculation. Bending moment equals force times distance. And these pylons are, by design, incredibly long.
That's an aesthetic choice, right, to get that silhouette.
Purely aesthetic. But the longer the pylon, the greater the leverage, and the stress on that joint increases exponentially.
So when the ship hits high impulse or gets hit by enemy fire, that pylon is absorbing immense dynamic forces.
Correct. The critique says that during combat or evasive turns, these long, thin structures would basically start acting like tuning forks. They'd just vibrate uncontrollably.
A tuning fork scenario under that kind of stress?
Yeah.
That sounds like a guaranteed failure.
It is. That vibration leads to what's called fatigue failure. If those pylons were made of any material we know of, without some kind of sci-fi intervention, they would tear themselves right off the hull.
So how do they make it work?
According to the author, the only way is the magical intervention of force fields, specifically the structural integrity field, or SEF. The design violates physics so badly that it needs active, powered countermeasures just to exist.
So we've got the pylons, which are a disaster waiting to happen. Let's move to the point that connects the whole front and back of the ship, the connecting dorsal, the neck.
In the author's assessment, the neck is the single clearest structural choke point of the entire design. It's linking two huge, separately loaded masses, the populated saucer and the heavy engineering hull.
And when you link two big masses with one thin column, what kind of stress are we talking about?
Catastrophic levels of shear stress and tensile stress. Shear is when forces try to slice the neck in half, and tensile is the pulling force trying to stretch it apart. According to the author, during any rapid maneuver, the forces on that thin neck are magnified by the inertia of the huge hulls on either side.
And there's zero redundancy. If a pylon fails, you lose an engine. If the neck fails.
You lose the ship, the whole thing. The critique calls it the decapitation risk. It's an unavoidable weak point that basically screams, hit me here, to any enemy.
Not to mention all the critical systems that have to run through it, turbolifts, power conduits.
All routed through a highly stressed single point of failure, yes.
Yeah. And the author even points to a case from the movies to prove this point, right?
He does. He references the destruction of the Enterprise in Star Trek Beyond, where the ship is literally sliced apart right at the neck. That specific vulnerability, according to the author, confirms that even in-universe, enemies know to target that weak link. It's a design choice that actively invites the destruction of the ship.
Which brings us to the biggest engineering cheat of all, the thing that makes this whole impossible structure possible. The complete and total reliance on the structural integrity field, the SEF.
This is, for old type, the fundamental violation of basic safety engineering. In the real-world bridges, airplanes, anything, the gold standard is fail-safe design.
Meaning, if your active safety system fails, the structure holds together on its own.
Or at least fails gracefully without immediate catastrophic results. But the Jefferies configuration, with its huge separated parts and unsupported beams, does the exact opposite.
It's fail deadly.
That's the author's term, a textbook example of fail deadly. The SIF isn't a bonus. It's the only thing preventing the ship from tearing itself apart under its own inertia, even just cruising at normal speeds.
So if the power goes out even for a second and the SIF drops, the momentum of the saucer section alone would just shear the neck right off.
Precisely. That reliance on a constantly powered high-energy field is a violation of every principle of safety and redundancy. If you lose power from a plasma surge or a near miss, the ship is toast. It's a design that uses tech to fight physics rather than a design that works with physics.
It's a terrifying thought. You can't just turn the ship off and park it.
It wouldn't hold its own shape.
Okay, we've established the ship is constantly trying to disassemble itself. Let's move on to Section 2, tactical liabilities. Because if the structure is that fragile, the command decisions in the design make it even worse. This is what the author calls the shoot me design philosophy.
And we have to start with the single most glaring tactical blunder, the exposed bridge.
This is a famous one, Roddenberry's rule, right? The command center has to be on deck 1, top center of the saucer, an aesthetic choice.
And a choice that, according to the author, puts the entire command staff in the most vulnerable location on the entire ship. They are literally sitting in a dome on the top surface, protected only by the main shield and maybe a thin layer of armor.
You contrast that with any modern warship.
The contrast is stark. Modern warships use a deeply buried combat information center, a CIC. It's deep inside the hull, protected by meters of armor, surrounded by redundant systems. Why? Because the enemy's #1 goal is decapitation. Take out the chain of command.
And Starfleet basically just hands the enemy that advantage on a silver platter.
According to old type, yeah. The command staff is sitting in a glass box on the roof. We see it happen over and over. One focused shot gets through the shields, a bit of debris hits, or a kamikaze run like a nemesis. And you can instantly kill the captain, the XO, the tactical officer, everyone.
And the author points out that Starfleet just refuses to evolve past this. They keep the exposed bridge even when a buried CIC is the obvious choice for a military ship.
He argues it's the psychological need for the captain to see out the window overriding the tactical need for survival. Even on later ships, they mostly stick to this vulnerability. It's aesthetics over the lives of your most critical people.
Speaking of things that look nice, but are tactically insane, let's talk about all the windows the Galaxy class is covered in them. Observation lounges, crew quarters.
And this is condemned as a massive structural and tactical weakness. It doesn't matter if it's transparent aluminum or whatever. According to Eximus Old Type, a window is, by its nature, a material discontinuity.
Meaning the window's material properties are different from the armor plate around it.
Correct. And that difference creates stress concentration points. So when the hull takes a hit or goes through rapid temperature change or explosive decompression, the weakest point is always where the materials change. Every single window, the author says, is a potential blowout point.
Why are they even there? What tactical information does a window give you that a sensor screen can't?
The author is blunt. He says the windows are tactically irrelevant. Space combat happens over thousands of kilometers, sometimes faster than light. Visual confirmation is useless. Sensors are vastly superior.
So they create a huge structural weakness just so the crew can look out.
That's the critique. And he goes further. He points out the physical reality of space itself. He calls it the pointlessness of the view because, over 99% of space is just pitch black. Those shots of stars streaming past are impossible unless you're moving at incredible speeds right next to them. The windows are an indulgence that adds massive risk for no benefit.
Let's go back to those vulnerable engineering parts. The exposed propulsion nacelles. We know they're a structural problem, but tactically they're just a giant target.
They are strategically exposed, yes. The nacelles are full of high-energy plasma, warp coils, matter-antimatter injectors, the heart of the ship's FTL capability. And the design puts them far away from the main hull, outside the most protected layers of shielding.
So why try to punch through the thick engineering hull when you can just shoot off the thin pylon holding the engine?
Any competent enemy, according to Eximus Old Type, would target the pylons or nacelles first, cripple the ship's ability to run away or maneuver, and you've won half the battle. You disable the warp drive, and now it's a slow, sublight target you can pick apart at your leisure.
And the consequence of losing just one of those nacelles is immediate and total loss of control, right?
That's where the CMCT flaw comes back with a vengeance. If one nacelle is destroyed or just loses power, the other one immediately generates uncontrollable asymmetric thrust. The force is completely unbalanced, and it sends the whole massive ship into a wild spin.
Instant chaos on the bridge.
Absolute chaos. The centrifugal forces alone could overwhelm the inertial dampeners. You'd have massive crew casualties, and you wouldn't be able to lock weapons on anything. The author insists this vulnerability, born from that aesthetic choice, is the critical tactical Achilles heel of the entire design.
That structural and external critique is just devastating. Let's move inside the hull now. Section 3, what the author calls engineering insanity and crew safety violations. We're going from the ship might break apart to the crew is actively being killed by their own workstations.
And this starts with the most persistent, most ridiculous failure in all of Starfleet history. The complete disregard for crew safety, specifically the total lack of seatbelts on the bridge.
We see it in almost every episode. The ship gets hit, and bridge officers go flying out of their chairs, smashing into consoles.
The author explains this is all due to inertial damper lag. The inertial dampening fields, the IDFs, are supposed to cancel out the insane G-forces of space travel, but they routinely fail to keep up with the sudden stresses of battle.
And according to Old Type, even a tiny momentary failure of that system would be catastrophic.
Let's use his numbers. Without IDFs, accelerating to warp would turn the crew into liquid. So let's say the IDF is 99.9% effective. If the ship pulls a 1,000-gram emergency turn, and the IDF fails to compensate by just 1%, the crew is still hit with a 10-gram impact.
And 10 Gs, even for a second without a 5-point harness, is often lethal. Broken necks, internal injuries.
Fatal. The author condemns this lack of basic safety equipment, something you find in every 21st century car, as a flagrant disregard for OSHA standards and crew survival. That visual of officers flying across the room is pure TV drama that actively endangers the entire command staff.
It's prioritizing drama over lives. Which brings us to the next thing, the one that's almost a running joke, but is terrifying for the crew. The exploding consoles.
This, Old Type argues, is a complete failure of basic electrical engineering 101. Starfleet consistently routes its high-energy power systems, the electroplasma system, or EPS conduits, directly behind the user interface panels.
Wait, did they route literal plasma conduits, the ship's main power lines, inches behind an officer's face?
That's the core of the critique. The author uses this vivid phrase, workstations as Claymore mines. When the ship takes a hit, the energy from the weapon detonates that high-pressure plasma conduit, which then explodes outward, showering the officer with superheated plasma and debris. That's the rocks and plasma that always injures or kills the crew.
I mean, in any modern design, you isolate your control circuits from your high-voltage power lines. That's just safety 101.
It's foundational. Yet Starfleet ignores it again and again. The author suggests it might be for some aesthetic reason, but the result is that every single workstation on the bridge becomes a lethal hazard waiting to be triggered. It guarantees that any hull damage instantly translates into bridge casualties.
And the danger isn't just at the consoles. Let's talk about main engineering, the heart of the ship. which the author calls a literal death trap because of the unshielded warp core.
The matter-antimatter reaction assembly, the source of almost unimaginable power, is typically designed as this exposed floor-to-ceiling column right in the middle of main engineering.
And it's often transparent. You can see the reaction happening inside.
And that transparency is the primary flaw, according to the author. A reactor with the power of a small star should not, under any circumstance, be made of glass, and it shouldn't be visible to the crew working next to it.
If you look at a modern nuclear plant, the reactor core is buried under meters of steel-reinforced concrete to contain radiation and withstand failure.
Exactly. And old type contrasts that with Starfleet. Engineers are working just feet away from the core, protected only by magnetic fields. If those fields fail, which they always do when the ship takes heavy damage, the radiation breach or explosion is instantaneous and fatal for everyone in the room.
So the visibility is purely for the TV audience, putting the crew in a position that violates every known standard for reactor safety.
It's a huge vulnerability, and it means the ship is completely reliant on an active system, the magnetic field, to prevent disaster. If you lose power, the core goes critical.
What about the ultimate failsafe? The system that's supposed to save the ship from that ticking time bomb.
The warp core ejection system. And the author makes a very grim, cynical point here. Across the next generation era, this ultimate failsafe has a near 100% failure rate.
Wow.
It's the one system designed to prevent total destruction, and it constantly jams or fails, usually leading to the loss of the ship anyway. It highlights a systemic inability in Starfleet engineering to prioritize reliable redundancy in their most critical safety systems.
It's hard to imagine why they'd keep using systems with that kind of track record. Okay, let's look at two specific advanced gimmicks that old type just tears apart for adding complexity and tactical weakness. First, the iconic saucer separation of the Galaxy class.
The intention, according to the author, is noble. You let the civilians in the saucer escape while the battle section fights. But tactically, he says it's fundamentally unsound.
Why? You're splitting one big warship into two parts.
You're splitting one strong shield bubble into two weaker, slower targets. Once the saucer separates, it has no warp drive. In the author's words, it becomes a sitting duck. It can only run at impulse, making it an easy target for any enemy with FTL capability.
And the mechanical complexity must be a nightmare.
Old type calls it that, a mechanical nightmare. You need massive synchronized latches. You need to instantly disconnect thousands of power conduits, data lines, structural supports, all while you might be under fire.
That's thousands of new potential points of failure.
Absolutely. The author asks, what happens if a latch jams? Or a conduit doesn't disconnect? The ship is stuck in this unstable, compromised state. It's an over-engineered feature for spectacle that actually makes the ship and its crew more vulnerable.
And the Prometheus class takes this even further, with its multi-vector assault mode splitting into 3 ships.
This is dismissed by the author as an even worse tactical gimmick. The core idea is flawed. Why would you want to split your resources? You're taking one strong shield bubble and turning it into 3 weaker ones.
And the individual sections become much easier to pick off one by one.
Precisely. The author contends that this whole mode relies on incredibly complex computer coordination to work. If that network gets jammed or hacked, which happens all the time in Starfleet combat, the whole thing fails. You could have friendly fire, collisions. It's a feature that adds massive risk for very little tactical payoff.
These internal critiques are just devastating. The ship not only invites external attack, but actively endangers its own crew. Let's move to Section 4, where we look at 2 massive, unavoidable physics problems the design completely ignores: thermodynamics and stealth.
We have to start with the heat problem. Starships generate enormous amounts of energy. Petawatts of power from the warp core, the impulse engines, life support. All of it generates waste heat.
Right.
Yet, according to the author, these ships have no visible way of getting rid of it.
And in a vacuum, you can't just cool off with a fan. Heat can only be radiated away.
That's the unavoidable law of thermodynamics in space. If you generate that much heat, it has to go somewhere, and the only way is through thermal radiation, which requires huge, high surface area radiators.
Which is why you see those giant radiator panels on more realistic sci-fi ships, like in The Expanse.
Exactly. Those panels are there to maximize the surface area for shedding infrared radiation. But you look at the Enterprise hull, it's smooth, it's sleek, it's often reflective, which is the exact opposite of what you need for efficient heat radiation.
So, Old Type's argument is that the ship should basically be cooking its own crew.
That is the contention. Without huge visible moriators, there's no way to shed that thermal load. He says the crew and the ship's delicate systems should cook alive within minutes of engaging the engines. The ship's ability to stay cool depends entirely on another piece of space magic, some kind of unspecified internal heat sink.
A design that looks cool, but is thermally impossible.
It's an aesthetic that violates the second law of thermodynamics, according to the author's critique.
The second major physics violation is visibility, or the complete lack of stealth. Starfleet ships, especially at warp, are just giant glowing billboards.
They're massive beacons, the glowing Bussard collectors on the nacelles, the huge deflector dish pushing aside interstellar gas, the lit-up warp grills. Old Type argues they make Starfleet ships giant beacons across the electromagnetic spectrum.
You can't sneak up on anyone when you're lit up like a Christmas tree.
That's his point. The amount of energy radiating from the ship, both visible light and infrared from the heat problem, would make them instantly visible to passive sensors from light years away.
So when a Starfleet ship tries to be stealthy, Old Type says that's physically impossible for this design.
He asserts it as an absolute fact. Any enemy using long-range passive sensors would spot the Enterprise almost instantly. It negates any tactical advantage of surprise. The whole design broadcasts its location to every hostile force in the quadrant, again prioritizing the visual look, the glowing blue nacelles over operational security.
It seems like the entire ship, from its very foundation to its visibility, is geared toward looking dramatic on screen rather than surviving in reality.
And that consistency is what brings us to the final section, Section 5, the sanctification of design. This is where Eximus Old Type really gets to the root cause of why these dangerous flaws keep getting engineered into ships for centuries.
He argues that the reason these flaws persist isn't because of some in-universe logic, but because of something he calls sanctification.
Sanctification. The idea that the iconic silhouette of the Enterprise, the saucer neck, secondary hull, nacelles on pylons, has become absolutely sacred.
It's become religious dogma, in his words.
Yes. For the entire franchise. Designers are forced to follow Roddenberry's original 1960s rules bridge on top, nacelles separated, even though those rules directly contradict good engineering and combat survivability.
So even if an engineer knows better, they can't build a starship that doesn't look like that starship. The franchise demands that aesthetic continuity.
Exactly. Old Type argues this credo box prevents any real evolution towards robust, realistic military designs, which would probably look a lot more compact and integrated, like the few exceptions Starfleet does have.
And that defiance of the dogma is what leads to those exceptions. Let's talk about the one the author actually praises.
Right, the Defiant class. He holds it up as proof that Starfleet can build a proper warship when they break free of the Jefferies configuration. The Defiant has an integrated hull, so the center of mass and center of thrust are aligned.
Which solves the torque issue and the need for those long, vulnerable pylons.
It does, and the bridge is semi-recessed, which helps with survivability. But because the Defiant doesn't fit the sacred template, it's treated as this weird, specialized ship instead of the standard. And this insistence on looks over function, the author concludes, guarantees fragility for most of the fleet.
Let's run through the author's final, brutal report card for these classes, based on structure, tactics, and safety.
Okay, we'll start with the Constitution class, the original Enterprise. It gets a straight F for everything, the author's verdict. It is a 1950s fantasy of spaceflight, structurally unstable and a tactical nightmare.
Next, the Galaxy class, the Enterprise D, big and luxurious.
Structure gets a D. They tried to lower the nacelles, but it's still a giant target with huge weak points. Tactics is a D, mainly because, as the author notes, carrying civilian families makes it totally unsuitable for frontline combat. Safety is an F for the exploding consoles and lack of restraints. The final verdict, a luxury hotel built on a bomb.
Wow. Okay, now the exception, the Defiant class, the one that breaks the mold.
This is noted as the only credible warship in the fleet, according to Old Type. Structure gets a B+A because its compact design fixes the core physics problems. Tactics is a solid B, but safety only gets a C.
Why the low safety grade on their best warship?
Because, the author notes, even though it's built better, it still has the same pervasive safety flaws. No seatbelts and those fatal EPS conduits routed behind the consoles. Even their best design warship needlessly sacrifices its crew to explosive hazards.
And finally, the Prometheus class, with its multi-vector assault mode.
This is dismissed as a tactical gimmick. It gets an F for structure because the splitting feature just compromises its hull and shield integrity. Tactics is a D, as the complexity outweighs any real advantage, and safety is also a D. It just introduces instability that endangers the crew for a flashy fight scene.
So the final verdict, according to Eximus Old Type, really leaves no room for debate.
Not at all. While it's visually stunning, the Enterprise, in any of its Jefferies configuration forms, is an engineering disaster. It's a ship designed for TV, reliant on space magic like the SFF and IDF just to exist. And if you took those fictional fields away, the author contends the ship would be instantly destroyed in a conflict governed by real-world physics.
It's interesting that the author didn't just stop at tearing it down. He actually proposed a solution.
That's right. Old Type designed a theoretical ship, the Phantom class, specifically to fix every single engineering issue he detailed. The CMCT alignment, the structural integrity, heat management, while still having an appealing look. It's his proof that form and function don't have to be enemies. The flaws exist because of choice, not necessity.
So we've walked through this comprehensive critique: the catastrophic CMCT offset, the failed deadly reliance on the SIF, the complete lack of thermal management, the fragile neck, the tactical blunder of the exposed bridge.
And the key takeaway, for you, the listener, is the universal insight this gives us into engineering. I mean, whether you're designing a starship or a skyscraper, good design demands a fail-safe approach. You have to respect the alignment of mass and thrust. You can't rely on constantly powered safety systems. And you definitely can't add structural choke points just because they look cool.
The design has to work with the laws of the universe, not invent new laws to constantly fight them. It's a really powerful cautionary tale.
And that brings us back to that central idea of sanctification. The author argues the Enterprise design is upheld by dogma. It looks the way it should look, regardless of how badly it works.
Which raises a really important question for you to consider, way beyond Starfleet. In our own world today, what common technological designs or even architectural conventions are we just accepting as dogma, simply because they look the way they should based on decades of tradition?
What designs are fundamentally fragile or inefficient, just waiting for their own ruthless, real-world critique because everyone is afraid to change that iconic silhouette? That is the structural challenge at the heart of all innovation.
Until next time, keep digging deeper.
We'll see you on the next deep dive.